This video is an introduction to multiplying matrices by using the product matrix method. So the product matrix method is the result of multiplying two matrices where the number of columns in the first matrix equals the number of rows in the second matrix. So we can only apply this method when that holds. So if we've got two matrices and we don't have the same number of columns in the first matrix as we've got the same number of rows in the second matrix, then we cannot use this method. So we can test it. Order of matrix A is going to be m times n. Remember, it's row and column. And then the order of matrix B is going to be P times Q. And again, it is row and column. We are looking to see whether the columns in matrix A and the number of rows in matrix B is the same. So we can multiply matrix A and matrix B if our n and p value is going to be the same. Let's have a look at how do we apply this to a practical example. So in our example, we have matrix A, and we have matrix B, and we want to show that we can use a product matrix AB. So to test it, we want to write down the order of both A and B. So the order of A is going to be 2 rows and 1 column, so it'll be 2 times 1. And then the order of B is going to be 1 row and 2 columns, so 1 times 2. And to be able to use a product mix, we need to have the same number of columns in matrix 1 as we do for rows for matrix 2. So having a look, we've got 1 column in matrix 1 or matrix A in our example, and we've got 1 row in our second matrix or matrix B. So therefore we do have a product matrix that we can use to multiply A and B together. And we can also write down the order of our new matrix when we multiply together, so AB. And the order is going to be the number of rows in the first matrix, so 2, times the number of columns in the second matrix. So in this example, it'll be 2 as well. So the order for our multiplied matrix AB is going to be 2 times 2. So that is an example of how we can check to see whether a product matrix exists and how we can write down the order of that product matrix.